Happy day to all. Today we are going to see UGC NET previous year questions in discrete structure subject. Yes, let's begin. What's the question here is, if f of x equal to x plus 1 and g of x equal to x plus 3, then f of. Okay, so first you consider what is f of f. The question is, first we have to find out f of f. That is, in the f itself you have to assign this f of x value. So what is f of x? First of all, x plus 1. So f of x value is x plus 1. So now this f of x means this f of x value x plus 1. Okay, this will be considered as x. Now you have to assign this x inside this f of x. So this x is x plus 1. Okay, then now this is only, this 1 will become as it is. Okay, so what happens, this will become x plus 2. Okay, f of f means this x value, f of x value you have to apply again into for this x value. Okay, so x is x plus 1 now, so x plus 2. So 2 f of f means x plus 2 happen. If how many f is there? 1, 2, 3, 4. So what will be the answer? X plus 4. So otherwise you can also see again one more f of f. So this f of you have to again apply to the x plus 1. So if you again applied the third f of f became x plus 3. Okay, f of f. So if you apply f of f, so then this will become x plus 3 plus 1. So x plus 4 is the answer. So x plus 4, how can you return x plus 4? So in this option x plus 4 is not present, right? But they said that g plus 1 or g of x plus 1. So what is the g of x plus g of x value? G of x equal to x plus 3. So if you write this g of x plus 1, you will get x plus 4, right? So you can say that B is the answer. So you can say that this f of f, this one is g of x plus 1, that is x plus 3 plus 1. You will get x plus 4. So this is also the answer, x plus 4, and this also x plus 4. Okay. And the next question is, the following list or the degrees of all vertices of a graph. So they are given that list or the degrees of all the vertices, degrees. So this is the degrees of all the vertices. Okay, this is the first vertex degree, this is the second vertex degree, this is third vertex. Okay, so they are given some set of degrees of vertices. What is degree? The number of connection between the vertices. So now vertices A has 2 degree. Okay, so B has 1 degree. Okay, C has 1 degree, for example I am telling. Okay, so now they are asking the following list of the degrees of all the vertices of a graph, this and all. Then which of the following above sequence or graphic? Which of the following above sequence or graphic? So what is Handshake Theorem says? Sum of degree of vertices equal to Handshake Theorem. As per the Handshake Theorem, sum of degree of vertices equal to 2 into edges. As per the Handshake Theorem. As per the Handshaking Theorem, sum of degree of vertices equal to 2 into edges. Okay, so how many vertices? It may be I to 1 to n. So if there are 5 vertices or 10 vertices, whatever it may be. So sum of degree of vertices equal to 2 edges, 2 into edges. So this is the rules. So if you find out this, so if you add this, this should be an even number. Okay, so this should be an even number. When you add all the degree of vertices, that should be an even number. So if you find out sum of this degree of vertices, find out the sum of all these values. So 3 plus 2, 5, 5 plus 10, this is 15. Okay, then this is 5, 10, 18, 24. 5 plus 4, 10, 24. Then this one is 5, 9, 10, 18, 25. And this one is 10 and 18. So which is the option is even number? So option 3 and option 4. Okay, option 3 and option 4 as even numbers. Okay, as per the handshake theorem, sum of degree of vertices equal to 2 edges. Okay, so when you multiply by 2, it will give only even number. So option 3 and 4 is the correct answer. Okay, so because this is the sum of degree of vertices is 24, and for this sum of degree of vertices is 18. So which one of the above sequence of graphic? Option 3 and option 4. The next question is, if Im denote the set of integer modulo m, then the following are fields with respect to the operations of addition modulo m and multiplication modulo m. So I am not sure about it, but when you compare this Z23, Z29 and Z31 and Z33. So 23, 29, 31 are prime numbers. 23, 29 and 31 are prime numbers. Okay. So 33 is not a prime number. So we have to neglect this value. So option 1 and 2 and 3 only is the answer. You check it out. And the next question is weighted graph. What is weighted graph? First, what is graph? A graph is consist of V, edges, vertices and edges. Vertices means you are represented with a circle node. So this is A vertex, this is B vertex, this is C vertex. So edges means this is the edges E1 and E2. Weighted graph means if you have assigning some value for this edges, then it is called as weighted graph. For example, from A to B, this is the distance is 2. Okay, this is called as weight. So weighted graph is a graph in which number associated with arc. It's a graph in which number associated with arc. So whenever you are assigning some value to the edges, then it is called as weighted graph. Okay, this is an undirected graph. It is not a bidirectional or directed graph. It's eliminative. It's not. Weighted graph means just you are assigning a weight, assigning some values to these edges. Okay, see here A to B, you are assigning a edge 2. Okay, for this edge I am assigning some value, that is called as weighted graph. Yes, the next question is the transitive closure of a relation R on set A whose relation matrix A is. Okay, this is relation. Okay, set A, consider this. So which will be equal to the transitive closure? First of all, we have to find out what is transitive closure. What is transitive closure? If A comma B is there and B comma C is there, then A comma C must be present, right? If A comma B and B comma C is present and A comma C must be present, this is called transitive closure. Okay, so this is called as transitive closure. So now you have to find out wherever 1 is present for this set A. Okay, they are asking what is the transitive closure for this A matrix. So what is this position? You consider this 1, 2, 3 row. Okay, this is 1, 2 and 3. So 1 comma 2 is there. So first of all, you write out wherever 1 is present in a first row and second column, and where another one is 2 comma 3. 2 comma 3 is there and 3 comma 1 is there. So if this is present means what is the equivalent transitive closure? So 1 comma 2 is there and 2 comma 3 is there. So 1 comma 3 must be there. Okay, if it is a transitive closure. So 2 comma 3 and 3 comma 1 is there. So you can write it as 2 comma 1 must be there in the transitive closure. So 1 comma 2 is there and 2 comma 1 is there. Then 1 comma 1 must be there. Right? So here 2 comma 1 is there and 1 comma 2. As per this, you have to write 2 comma 2 must be there. And see 3 comma 1 is there, 1 comma 3 is there. So 3 comma 3 must be there. Right? Then 3 comma 2 comma 2, 3 comma 3 comma 1 and 1 comma 3, 3 comma 3. So then next one is 2 comma 2, 1 comma 1, 1 comma 2, 1 comma 3, 2, 1, 2, 2, 3, 1, 3, 2. So now you see what else? 3, 1 and 1, 2. So you can written as 3, 2. So as per this, 1, 1 is present. So the transitive closure is, so 1, 1 must be present and 1, 2 must be present and 1, 3 must be present. And 2, 1 is there. 2, 1, 2, 2. See 2, 1, 2, 2, 2, 3. So this row should be 1. And 3, 1, 3, 2, 3, 3 is there. So this row also should be 1. So the equivalent transitive closure of a relation or on set A whose relation matrix, this matrix. So this is the given matrix. The transitive closure of this matrix is option C. Okay. So option C is the equivalent transitive closure. Clear? Yes. The next question, consider the relation on the set of non-negative integers defined by x. This means x congruent y if and only if. If and only if. Congruent means if the mod value of this, if the mod value of this and this should be equal, then it's called as x congruent to y. For example, 7x mod 3 equal to y mod 3. Okay, 7 mod 3 is 1 and 10 mod 3. So what is the remainder value? Here also 1 and here also 1. So 7, 10 is congruent to this. So option C is the correct answer. So option C is the correct answer. The next question is minimum number of individual shoes to be picked up from a dark room. So there is a dark room. The minimum number of individual shoes to be picked up. Okay. Containing 10 pair of shoes. 10 pair. Remember 10 pair of shoes. Okay. So 10 pair of shoes means what? 20 shoes are there. So 10 pairs. If we have to get at least one proper pair. If I want to get one proper pair, okay, proper pair, then how many shoes I have to take? At least one proper pair I need. Okay, it may be 10 different shoes. So after taking 10 shoes, if you are taking 10 different shoes and if you are taking the 11th shoe, that must be matched with any one of these 10, right? If you are taking 10 shoes, consider if you are taking 10 shoes from the bag or from the dark room, the 10 shoes may be different one. But if you are taking the 11th shoe, that must be matched with any one of that 10 shoes because only it consists of only 10 pair of shoes. So if you are taking the 11th shoe, that must be a proper pair for one shoe. So if you are taking 11th shoe, it will be one proper pair for some color, right? So option C is the correct answer, 11. So if you are taking 11 shoes, you will get at least one proper pair. The next question, which of the following statement is false? They are asking which of the statement is false. The first one is every tree is a bifurcate graph. Bifurcate graph means you have to divide it by 2, 2, 2, 2. Okay. So this is called as tree. So this is a tree structure. So every tree is a bifurcate graph. A tree contains a cycle? No. A tree with n nodes contains n minus edges. Yes, correct. See, this is a tree, okay. So here there are 3 edges and 3 vertices. Okay, 1, 2, 3 vertices, but edges are 2. Okay, so n minus 1 edges. A tree with n nodes contains n minus 1 edges. So that is also correct. The next one is exact definition is a tree is a connected graph. A tree is a connected graph. A tree is a graph, not a graph. A tree is a connected graph. Connected graph means it should connect all the vertices. Okay, it should connect all the vertices. So a tree contains a cycle? No, a tree should not contain a cycle. A tree should not contain a cycle. So that they are telling that if there are n nodes, it must be n minus 1 edges. See, if there is one more edge, the cycle will be formed, then it is not a tree. Right? So they are asking which statement is false. So a tree contains a cycle. So that is false statement. So they are asking option false statement. So B is the correct answer. The next question is if X is a set and the set contains an integer which is neither positive nor negative, then the set X is what? Set is empty, set is non-empty, set is finite, set is both non-empty and finite. See, first of all, understand the question. If X is a set, so X is containing some set of values, set values whose the condition is it's neither positive, it is not a positive number, and also it is not a negative number. So what such a number is? It is nothing but 0. 0 is neither positive nor negative. Okay, so now the set X is contains 0, that is one element. So it contains one element. So it is called as an finite. It is called as an finite number of elements. If you are able to count number of elements in a particular set, then it is called as finite. Okay, so set is empty? No, it contains one element. Set is non-empty? No. Set is finite? Yes. So you can able to count number of elements in a particular set. That is called as a finite set. Okay, set is finite. Set is both non-empty and finite? No. So set is finite. Option C is the correct answer. Okay. The next question is, consider the graph. Which of the following is valid topological sorting? Valid topological sorting means it should come in the particular arrow. The arrow has to be, the path must be present. Okay, so this is consider option A. So A to B and B to C and C to D is there is no direction. The no direction is present. So option A is the wrong one. You consider the B option. First of all started with B and I am going for A. From B to A, is there any arrow is there? No. So this option is not correct. Okay. So then option C. So from B, if it is possible to go from B to A, no. So this is also wrong. So consider the option D, A, B. So from A to B I can go because the direction is there. So A to B and B and then D. So B to D it is going. Then D to C. So here also arrow is coming this side. So A, B, D, C. So this is a valid topological sorting. So in this way I can traverse this graph, right? If in a directed graph, if the direction is present, then only I can traverse. For example, from A to D I can go. D to A I can't go because there is no direction, right? So A, B, D, C is the valid topological sorting. The next question is, let A x equal to minus 1 x 1. So the x value will be, so the x value in between minus 1 and 1. So it may be any real value. Okay. So the function x equal to x divided by 2 from A to B is always both injective and subjective. 1 to 1 is called as injective. Okay. And 1 to many is subjective. The next question is the number of edges in a complete graph. The number of edges in a complete graph with n vertices is equal to n into n minus 1 divided by 2. So the number of edges in a complete graph with n vertices. For example, consider this 3 vertices. 3 vertices are connected with all these 3. So totally how many edges? So number of vertices is 3. So 3 minus 1 is 2. So divided by 2, you will get 3 edges, right? Yes, the number of edges in a complete graph with n vertices is equal to n into n minus 1 divided by 2. So apply how many n? N is the number of vertices. If you apply the value of n, you will get number of edges. The next question is, if a square, this one is a square minus b square, they are telling that if a square minus b square is a prime number where a and b is an element of n. A and b is element of n. N is what? Natural numbers. Okay. So they are telling that a square minus b square is a prime number. Okay. Prime number must be not divided by any value, right? So prime into 1. I can say this as an equation. A square minus b square equal to prime into 1. Okay. So they said that it is a prime number. So a square minus b square can be written as a plus b into a minus b. Since they said that it is a prime number and a should be greater than b. Okay. Because it is a prime, there is not negative value. If a is lesser means what happened? Minus value will come. Okay. So a plus b, a minus b equal to prime into 1. So I can say that a plus b equal to prime and a minus b equal to 1. So if a minus b equal to 1, okay. So I can written as, so if a minus b equal to 1, how can I written this equation? So a square minus b square equal to a plus b. So option C is the correct answer. The next question is, a box contains 6 red balls. A box contains 6 red balls and 4 green balls. 4 balls are selected at random from the box. Okay, 4 balls are selected at random from the box. What is the probability that 2 of the selected balls are red and 2 are green? So first, probability can be represented as total number of total events. Okay, possible event. For example, for tossing a coin, there are 2. Okay, 1 and 2. In that I am to get a tail. That is 1 by 2, we are telling, like, right? So now if you consider in the same way, a box contains 6 red balls and 4 green balls. So totally how many balls? Totally how many balls? 10 balls. So 10 balls are there. 6 and 4. 6 red balls and 4 green balls. So totally how many balls? 10 balls are there. 4 balls I am going to select at random from the box. 4 balls are selected. So from the 10 ball I am going to select 4 balls. So that is represented as 10C4. From the 10 balls I am going to get 4 balls. Okay. They are asking, so the possible event is, what is the probability that 2 of the selected balls are red? Okay, so how many red balls are there? 6. So total 6 red balls, I need 2 balls. So you can represent as 6C2. 6C2. Okay, and then 2 are green. So 4C2. From the 4 balls, I am going to get 2 balls. Okay, from the 6 balls, I am going to get 2, and from the 4 balls, I have to get 2. So now we have to apply NCR formula. What is NCR? N factorial divided by R factorial into N minus R factorial. So that is a formula we have to apply here. Okay, NCR equal to N factorial divided by R factorial into N minus R factorial. So for 6C2 equal to 6 factorial, first I am finding 6C2, 6 factorial divided by 2 factorial divided by 4 factorial. So 4 factorial will cancel. So 5 into 6 into 1 into, here 1 for 2 factorial, 1 into 2. So that will become 15. Okay. So 6c2 is 15. So now I have to find out 4c2, that is equal to 4 factorial, 2 factorial, 4 minus 2, 2 factorial. So 2 cancel. Remaining is 3 into 4 and 1 into 2. So if you cancel 2, so 3 2s are 6 is the answer. And for 10c4, that is equal to 10 factorial divided by 4 factorial, 6 factorial. So 6 factorial will cancel no in the power. So 7 into 8 into 9 into 10. Again 1 into 2 into 3 into 4. So 4 2s are 8. This will cancel and this one is 3. So 7 3s are 21 and 21 10s are 210. So if you apply the value here, so 6c2 value is 15, 4c2 value is 6 and this one is 2 10. Okay. So if you cancel in a 3, 5 3s are 15 and 7 3s are 21, right? So if you again cancel 1 5s are 5 and 4 5s are 20. So if you cancel again 3 2s are 6 and 7 2s are 14. So 3 by 7 is the answer. So 3 by 7 is the answer, probability. So which is available in the option A. Okay, just remember this NCR formula, n factorial divided by r factorial into n minus r factorial. Apply that and see the result. The next question is the number of edges in a complete graph with n vertices equal to n into n minus 1 divided by 2. The next question is the set of positive integers under the operation of ordinary multiplication. So when I am doing ordinary multiplication, this is not a monad, not a group, abelian group. So first we have to know what is monad, group and abelian group. The next question is the set of positive integers under the operations of ordinary multiplication is. Okay. So first of all we have to know what is semigroup, monad, group and abelian group. Okay. Semigroup means which is consist of closure and associative property. Closure and associative property. And monad means closure, associative, identity property. Closure means A star E equal to E star A. Okay, and then associative A plus B plus C, you can bracket A plus B and then you can also written as B plus C and then if you do that, okay, associative. Identity means just A some operation of E equal to A. For example, 5 plus 0 equal to 5. So here 0 is the identity element for addition. For addition 0 is the identity element. For multiplication 1 is the identity element. Okay, for multiplication associative also come. And then for group, closure property, associative, and I am denoted this quotation means all the monad properties will come in the group. That is, group means closure, associative, identity and inverse. Okay, A divided by 1 by A dot A inverse equal to identity element E. Okay, so if you A into 1 by A, that is equal to 1. Okay, so 1 is the identity element for multiplication. So that is also executed. So for abelian group, closure, associative, identity, inverse and commutative law. So closure, associative, identity, inverse and commutative, everything will be come under for the natural numbers, ordinary numbers in a multiplication. So this will be come under the abelian group. This will come under an abelian group. Yes, the next question is, in a set of 8 positive integers, there always exists a pair of numbers having the same remainder when divided by which number? So this we cannot identify. So just remember this 2, 9, 16. So when you divide it by 7, okay. So when 2 mod 7, the remainder is 2. And similarly 9 mod 7, that is equal to 2. And 16 mod 7, that is equal to 2. Okay, so there always exists a pair of numbers having the same remainder. So this pair of numbers having the same remainder in all the cases when you divide it by 11. Okay, but which is not happen in 11, 13 and 15. So option A is the correct answer. Okay. Yes. The next question is the graph K 3, 4 has how many edges? Okay, 3, 4 is what? 3 bipartite graph. Okay, so one set consists of three vertices and another set consists of 4 vertices. So totally how many edges you may have? So m comma n have n edges, m dot n edges. That is 3 into 4, that is equal to 12 edges are possible. For example, this node can connect with this 1, 2, 3 and 4. And this node may connect in a complete bipartite graph. Okay, so 3, 4 plus 4, 8. And this node may connect with all other nodes. So, how many edges? 12 edges are there. Okay, so option D is the correct answer. And the next question is a relation or in 1, 2, 3, 4, 5, 6 is given by 1, 2, 2, 3, 3, 4, 4. So the relation is, so what is, they are asking this relation is what? Either it is reflexive or symmetric, transitive. So what is reflexive? If x is in the relation, x, x must be in that relation. Okay, so 1 is in relation set or then 1, 1 must be in the relation. If 2 is there, 2, 2 must be there. 3 is there, 3, 3 must be there. So that it will called as reflexive. But here 1 is there in the relation, 1, 1 is not present. 1, 1 is not in the relation. Yes, so it is not reflexive. This is not reflexive. The first one is reflexive. X is present, x, x must be present, then it is called as reflexive relation. So here there is no reflexive relation. And then check symmetric. What is symmetric? Symmetric means a, b is present in the relation, then b, a must be present in that relation. Then it is called as symmetric. For example, 1, 2 is in the relation. So 2, 1 must be in the relation. So 2, 1 is not in the relation. So it is not a 1, 2 is there, but 2, 1 is not in the relation. So it is called as a not symmetric. This is not a symmetric relation. Okay, and then transitive relation. 1, 2 and 2, 3, then 1, 3 must be present in the relation. So 1, 3 is not present in the relation, right? 1, 2 is there, 2, 3 is there, but 1, 3 is not present in the relation. So this is not a transitive relation, not transitive. Okay, a, b, b, c is there and a, c must be in the relation, then only we can call it as a transitive relation, right? But here, so it is not a reflexive, this is not a symmetric, and this is also not a transitive relation. So option D is the correct answer. And the next question is, if she is my friend, okay, if a particular person, she, consider x is my friend, okay, and you are her friend, okay, x, you are her friend. Okay, x friend is y, but my friend, okay, I consider myself, z friend is x. Then we are friends, then z and y are friends. Then this friend relationship in this context is, so they are telling it is just a statement, sorry, she is my friend, so x tends to z, okay, like this, and you are her friend, okay, so then we are friends. So this is not coming under either commutative or transitive or implicative or equivalence. So none of the above is the answer. The next question is, or is a robot of, or is a robot of. M dash means R can perform some of the task that otherwise M would do. R is a robot of M dash means R can perform some of the task that otherwise M would do. R can perform some task, okay, some task of M that otherwise M would do. Okay, if R is then you think that R is the subcategory of M. Okay, M is higher than R. Okay, see in this statement M would do and R is unable to do anything else. Which of the following is most appropriate represent or to model this situation? So R can do some of the work, but for some situation M can do more than R. Okay, this part R is unable to do. Okay, R is a robot of M dash means R can perform some of the tasks that otherwise M would do. R is unable to do anything else. Which of the following is the most appropriate representation? So R will come under M. Okay, so if you see which option is there, B option is the exact one. Okay, R will come inside M. So this will be R. So this is R and this will become as M. So option B is the correct answer. The next question is the number of integers between 1 and 250 that are divisible by 2, 5 and 7. So remember the numbers that are divisible by 2, 5 and 7. It is not R. So 2, 5 and 7. If I want to divide it by all these numbers, okay, for consider if 1 to 100, how many numbers are divisible by 2 and 5? So 2 and 5 means 10. So all the numbers which is divisible by 10. So in the same way here 2, 5 and 7. That means 2 into 5 into 7. Okay, 10, 70. So total number of digits is 250. So 250 divided by 70. This will become under 3 7s or 21. So 3 numbers, number of integers between 1 to 250 that are divisible by 2, 5 and 7 is 3. Okay. So this 250 divided by this all the numbers, because they are telling that that number should be divisible by 2, 5 and also 7. So we should multiply 2 into 5 into 7. So 70. 250 divided by 70 will get the 3 numbers. Okay. The next question is an undirected graph possesses an Eulerian circuit. What is an Eulerian circuit? If and only if it is connected and its vertices are all of even degree. Okay, when the graph will be say as an Eulerian circuit, if it is the vertices are all of having an even degree. What is even degree? See, this is an for example so Eulerian circuit, okay, all possess the even degree. This one is 2 and this one possesses 2 and this one possesses 2. For example, so A degree of vertices is, so Eulerian circuit only if it is connected and its vertices are all of even degree. So even is, see this degree is 2, B degree is 2, C degree is 2. So all the vertices degree is 2. Then it is called as an Eulerian circuit. If all the vertices degree is even degree, then it is called as an Eulerian circuit. So an undirected graph possesses an Eulerian circuit if and only if it is connected and its vertices are all of even degree. Okay. The next one, a partially ordered set is said to be lattice. A partially ordered set is said to be lattice if every 2 elements in the set have. So what is poset? Partially ordered set. Poset is nothing as every 2 elements in the set have unique least upper bound and unique greatest upper bound. For example, 2, 6. Nothing but least upper bound is greatest common divisor. Okay, GCF, greatest common factor. So the greatest common factor is 2 equal to 2 into 1, 6 can be written as 2 into 3. So the greatest common factor is, that is, the greatest common factor is called as least upper bound. Greatest common factor is also called as least upper bound. Okay, so the least upper bound value is 2, and LCM is greatest upper bound, greatest lower bound. Greatest lower bound, that is for 2, 6, you can say that 6 is the greatest 2 into 3. So 2 into 3 is the 6, is the greatest lower bound. So every partial order set, if you consist of any set of elements, you will have 2 elements in the set here, that is unique least upper bound and unique greatest upper bound. For example, 2, 6 and 3, 6, 9. What is the unique least upper bound and unique greatest upper bound? So 3 is the 3 is the GCF, and another one you have to find out the LCM. So unique least upper bound and unique greatest lower bound is the answer. That is available in the option C, both A and B. A partial order set is said to be lattice if every 2 elements in the set have a unique least upper bound and unique greatest lower bound. So both A and B is the answer. See here, the question is the minimum number of edges. Okay, normally they were used to ask the maximum number of edges in a connected graph in n vertices is equal to, but here they ask minimum number of edges. Okay, so in a graph, minimum number of edges I need, so if there are 3 vertices, I need 2 edges. Okay, if there are minimum is n vertices are there, I need, if I want to connect all the vertices, I need minimum n minus 1 edges. Okay, they are not asking maximum or complete graph, they are asking the minimum number of edges in a connected graph with n vertices is equal to option D, n minus 1. Okay, the maximum number of edges, then only n into n minus 1 by 2, maximum number of edges. Okay, yes. The next question is, consider the problem of connecting 19 lamps to a single electric outlet by using extension cords, each of which has 4 outlets. The number of extension cord is required. Okay, 19 lamps are there to connect 4. Okay, this is extension cord 1. Okay, E1. So there are totally 19 lines, no? So this is lamp 1, lamp 2, lamp 3, 1, 2, 3, 4. So first 4 is connected with 1, and another 4 is connected with extension 2, and another 4 is connected with extension 3, and another 4 is connected with extension 4. So how many it happened? 4 lines, 8, 12, 16. 3 more lines are there, right? 3 more lines are there. So and then this line 1, 2, 3, 4. So these 4 lines are connected with extension E5. Okay, now this line is coming, and then this 1 line is there, 2 line, 3 line and 4 line. This 17 and this you can combine 4 lines. Okay, now you can use another extension cord to combine these lines. So extension 6. So you will connect all the lines. So 6 extension cord is required for this. So the problem of connecting 19 lamps to a single electric outlet by using extension cord, each of which has 4 outlets. Okay, this is a 19 lamps. Okay, 1, 2, 3, 4. This is 4 lamp, 5 lamp, 6 lamp, 8, and then this is lamp 9 up to lamp 12, this is lamp 13, and this is lamp 14, lamp 15 and lamp 16. Okay, these lines are must to connect to a single line using how many extension cords? So that is the question. Okay, the number of extension cord required is, so I am connecting first 4 lines, and then I am connecting 4, and then connecting 4, and then 4, and then this 4 lines will be connected, and this and 3 more lines are there, right? So they are asking minimum extension cord. So you connect this. So 6 extension cord is required to connect all these 19 lamps. Yes. The next question is any integer composed of 3n identical digits divisible by 3 power n identical digits is divisible by 3 power n only. Okay, for example, 3 power n consider 1, 1, 1. So this will be divisible by all this 3. Okay. The next one is domain and range of the function. Domain is y equal to minus root of minus 2x plus 3. So take square on both the sides. Okay, so y square equal to minus 2x plus 3. So then it will become a quadratic equation. So y square plus 2x minus 3 equal to 0. So what is the value? So now consider y equal to 0. Now consider let y equal to 0. What happens? 2x minus 3 equal to 0. So x equal to 3 divided by 2. So x should be less than. So when y is less than or equal to 0, x equal to or greater than 3 by 2. So option C is the correct answer. The next question, maximum number of edges in a n-node undirected graph without self-loop. Without self-loop is also, it will be same like undirected graph. So here also n into n minus 1 divided by 2 for the complete graph. For a maximum number of edges in a n-node undirected graph. The next question is, what is the probability of choosing correctly an unknown integer between 0 and 9 with 3 chances? Actually, this is the wrong options, and in NET also they are giving different answers. Okay, so I skip this question. You just work out on yourself. The next question is the number of colors required to properly color the vertices of every planar graph. Every planar graph. So according to the color theorem, okay, according to the color theorem, every planar graph requires every planar graph requires 4 colors to complete the planar graph. So according to the theorem, they says that the number of colors required to properly color the vertices of every planar graph is 4. Okay, and this, the next question, let q of x comma y denote x plus y equal to 0, and let there be two quantification given as for all x, that is q of x comma y for all x for some y. Okay, so you will get this answer. Okay, where x and y are real numbers, then which of the following is valid? Okay, so x plus, so they are telling that for all x some y you will get the answer. Okay, so they are telling this one is true and this one is false. So kindly check this by yourself. The next question, how many relations are there on a set with n elements that are symmetric and a set with n elements that are reflexive and symmetric? So here the equation is 2n power n plus 1 divided by 2, and for reflexive and symmetric 2 power n into n minus 1 divided by 2. Okay, this is 2n power n plus 1 by 2 reflexive relations, and for reflexive and symmetric there are n elements, and how many relations that are reflexive and also symmetric is 2 into n power n into n minus 1 divided by 2. So The next question is, let A into H and B into H be two coset of H. Okay, so either A star H and B star H are disjoint. Yes. So A star H and B star H are identical? No. So only one is true. The next question is, which one of this graph or planar graph? So G1, okay, we cannot split this, okay. Planar, what is planar graph? So no edges will intersect each other, right? So no edges will intersect each other, it is called as a planar graph. So if I able to draw the edges, is it possible for this edge B to F? So this is intersecting, right? So we cannot take this. So I can draw C to D like this, but I cannot take this. So if I take in this way also, it will intersect with another edge. So G1 is not planar graph, okay, but G2 is planar graph. So it will be look like a cuboid. So the G2 graph can be represented like this. If we draw like this, so now no edges are intersected. Okay, we have to just remember this. Okay, so G1 is not a planar graph, but G2 is a planar graph. And the next question is the power set of the set null. So the power set is also, this null is also have an element. Okay, for this, so 2 power 0, so 2 power 1, okay, so n elements. So what is the power set is 2 power n. So here number of elements, 1 element is there. So 2 power 1 equal to 2 elements must be there. So null is 1 element and another one is again null is one more element. Okay, so option B is the correct answer. The next question is, suppose that someone starts with a chain letter. Okay, so remember, suppose that someone starts with a chain letter. This is one. Each person who receives the letter is asked to send it on to 4 other people. So here if this person is receiving one letter, so he must send that letter to 4 other people. Okay, so up to these 2 lines clear. Suppose that someone starts with a chain letter. So he is starting with a chain letter. So he is receiving some letter A. This person, each person would receive the letter. They are asked, okay, I am asking A to send it on to 4 other people. Okay, I am asking A to send it to 4 other people. Clear? Yes. Some people do this. Okay, so those who are receiving, this person is receiving means some persons will, for example, in a WhatsApp group, send it to 5 people, send it to 10 people. Yes, some people are sending to the other people, while some do not send any letter. Okay, up to 3 lines clear. Some people are sending to 4 people, but here these 3 people are not sending the letter, but these persons are sending. Okay, clear this 3 statement? Yes. The next statement says, how many people have seen the letter? How many people means totally this. So totally how much? It may be this 4 into x. Okay, I don't know how many. So 4 into x, then initially root is 1. Okay, how many people have seen the letter including the first person? Okay, if no one receives more than one letter, and if the chain letter ends after there have been 100 people, okay, after they have been 100 people, so up to 100 people who read it but did not send it out. Okay, also find out how many people sent out the letter. Okay, so these persons, or they're asking who read it. So if I'm sending, this person is sending all the 4 people, they are all reading. Okay, but these 3 people are not sending, but this person is sending out. Okay, they're asking who read it but did not send it out. Also find how many people sent out the letter. So how many people sent out the letter, and how many are not sent. Okay, so first, how many they can send the letter, that must be 4x, right? So this person sent 4 and this person sent 4, so 4x plus 1. Okay, this is root. Okay, so 4x, that is multiples of 4. Okay, so 4x plus 1, that should be, they said the total number of people is 100. Total number of people is 100. So 4x plus 1 equal to 100 people plus x. So if you subtract 4x minus x equal to 99, if you take this one this side, so 3x equal to 99, x equal to 33. If x equal to 33, total number of peoples will be 100 plus 33. So 133 is the answer. So the 133, 33. So option C. Who read it but did not send it out. Okay, so totally 133. Also, how many people who sent out the letters, who are sending the letters to 4 people. So that is 33 is the answer. The next question is, 2 graphs A and B are shown. Which of the following statement is true? So A is planar. Yes. So this graph, this edge I can draw like this. So graph A is planar. So no edges are intersecting with each other. So in this graph B, I can draw like this. Okay. So edges I can draw like this. So no edges are intersecting. No edges are intersecting, then it is called as an planar graph. So graph A and graph B both are planar graph. So both A and B are planar. And the next question, the number of distinct bracelets of 5 bits. So I am not clear about this. The option is C, 51. Check it out. And the same outlet question, 58 lamps are to be connected to a single electric outlet by using an extension cord, each of which has 4 outlets. Okay, so 58 divided by 4. So 1 4s are 4, then remainder 1, 4 4s are 16, right? So initially 14 cords are required. Initially, how many extension cord is required? 14. Okay, and then this 14 and remainder is 2 lines. 2 lines are remainder. Okay, 1 2. So remaining lines I am just drawing. Remaining is 2 lines are remaining. Okay, I am just drawing this. Just have it. So this 14 lines. So then 14 is divided by again 4. So how many I required extension cord? 14 divided by 4. So just you have it. So first time it required extension cord is 58 divided by 4, 14. Okay, and the remainder line is 2 lines. Just draw it. And then this 14 extension cord I have to again connect it, right? 14 divided by 4. So 3 4s are 12. Okay, so and then again I need 3 extension cords. 3 extension cords I require, right, to combine in the next stage. Okay, so here again 2 is remainder. Again in a step 2, 3 4s are 12 and the remainder is again 2 lines. Okay, again this remainder is 2 lines. To combine these 4 lines I need, so the remaining 4 lines is combined with 1 extension cord. Okay, this line is coming and this 3 plus 1 line is connected and 4. So this 4, again I need one extension cord. Okay, see 3 lines plus this 1 line, 3 lines plus this 1 line, 4 lines. And after these 4 lines to combine into one line, I need one extension cord. So totally 14 plus 17 plus 18, 19 extension cord is required to connect all the lights. Okay, just work out it, you will get the answer, very easy. And the next question is the power set of A union B is. So this is set A and this is set B. So first you have to find out A union B, that is 2, 3, so if you just do a union, 2, 3, 5 is 2 times present, so you just write it on one time, 7, 8, 9. So how many numbers are there? 1, 2, 3, 4, 5, 6. So the power set will be 2 power n. Power set of formula is 2 power n elements. So 3, 4, 5, 6. So 2 power 6 equal to 2, 4, 8, 16, 32, 64 is the answer. So option B is the correct answer. The next question is the number of ways to distribute n distinguishable object into k distinguishable boxes so that ni objects are placed into box this equals which of the following. So this is a formula, we have to just remember it, n factorial divided by n1, n2, n3 up to nk. The next question is a test contains 100 true false questions. Okay, 1, 2, 3 up to 100 questions. Okay, either it may be true or it may be false. Okay, how many different ways can a student answer the question on the test? If the answers may be left blank, so blank is also one option. So how many ways he can do is, so this is 3 power 1 first time and then 3 power 2 next time, 9 options. Okay, so if you consider this, so 3 power 100 is the answer. This is not 300, 3 power 100 options are there to answer this question. And the next question is which of the following connected simple graph has exactly one spanning tree? Which of the following connected simple graphs has exactly one spanning tree? So it is not like complete or Hamilton, it is none of the above is the answer. So every graph maybe have a different kind of spanning tree, right? The next question is the relation divides on a set of positive integers is. The relation divides on a set of positive integers. So consider 2, 4, 6, 8, 10. So if you consider set of positive integers, this may be symmetric and transitive. So consider a, b. If a, that is a is divisible by b, b should be divisible by a. Is this possible? If 4 is divisible by 2, but 2 is divisible by 4? No. Okay. So then it is not a symmetric relation. Not a symmetric relation. So that you can represent as anti-symmetric. If a divided by b, b divided by c, then a should be divided by c. For example, 8 divided by 4, 4 divided by 2, so 8 is divided by 2, correct. So it is a transitive relation, right. So the relation divides on a set of positive integers is antisymmetric and transitive is the answer. The next question is a vertex cover of an undirected graph G, U, V, A is a subset of vertex 1 is subset of B vertex such that, okay, it is nothing but if u comma v is an element of E, then u is an element of vertex 1 set, or v should be an element of vertex set. For example, this is u and v, this is a graph, and this must be come under the vertex graph, right? So u should be an element of v1 and v should be the element of v1. So option C is the correct answer. The next question is, find the number of ways to paint 12 offices so that 3 of them will be green, 2 of them pink, 2 of them yellow, and the rest one white. Okay, rest means remaining will be colored white. So 12 offices are there. Number of ways to paint 12 offices. So 3 of them will be green, 2 of them will be pink, and 3 of them will be green, 2 of them will be pink, and 2 will be yellow. The rest is 3 plus 2 5, 5 plus 2 7. So totally it is 12. 12 minus this, that is equal to 5 7, that is equal to 5 is white. Okay. So totally it is 12 factorial divided by 3 factorial, 2 factorial, 2 factorial, 5 factorial. So 5 factorial, 5 factorial will be cancelled. So I am writing 6, 7, 8, 9, 10, 11 into 12 in the upper part. And then if you write 1 into 2 into 3, I am writing 6 factorial. I am writing overall. So for 2 factorial it is 2, and for 2 factorial it is 2. Okay, 6 will cancel, and 2, this will be cancelled 4 times, this will be cancelled 2 times. So if you multiply 7 2 so 14, 90, 990, okay, 990 into 14, so 400, 4 9 so 36, 36, 39, and 990, so 0, 6, 9 and 18, 8 remainder 1, 13. So if you multiply again by 12, okay, 13860, if you will get 1,66,320 is the answer. So option B is the correct answer. The next question is, consider the following statement: a graph in which there is a unique path between every pair of vertices is a tree. There is a unique path between every pair of vertices in a tree, correct. A connected graph with edges equal to vertices minus 1. For example, edges is 2, vertices minus 1. Yes, 3 vertices and edges should be 2 in a tree. In a tree, a connected graph with edges equal to vertices minus 1. That is a tree. So this statement is also correct. The next statement is a graph with edges equal to vertex minus 1 that has no circuit is a tree. That has no circuit is a tree. Correct. That is no cycle in a tree. So that's also correct. So all the above is the answer. So this is a birthday problem. I am not aware of this. So the answer is at least 23. And the next question is, let f and g be the function from a set of integers to the set integers defined by f of x equal to 2x plus 3 and g of x equal to 3x plus t. Then the composition of f and g and f. So f of gx they are asking. So f of gx is 2x plus 3. This is f of x, right? Here you have to apply this 3 of x plus 2. So 2 into 3x plus 2 plus 3. Understood? This g of x must be represent as an x in the place of x. Okay. So now what is the value? 6x plus 4 plus 3. So 6x plus 7 is f of g. Okay. And g of f of x. So take what is g of x? 3x plus 2. So now apply in the place of x. Okay. In the place of x I have to apply what? 2x plus 3. Okay, 2x plus 3 I have to apply here. So this 3 you consider as it is. So 6x plus 9 plus 2. So 6x plus 11 is the answer. GO of x and f of x is 6x plus 7. This is available in the option A. So up to this 50 questions are completed. So part 1 is completed. I will see you on the part 2 video. All the best, friends.